All right, so we'll continue taking a look at Chapter 7. Section 7.3, as I said earlier, kind of broken into three parts. The first part is 4 special properties of logs to simplify them. The second part is taking logs that are separate and combining them together. Or we can take one that's combined together and split it apart. You can do it either way. And the fourth thing is how do you type in logarithms on the calculator that are not base 10 or base e? Because right now, those are the only two we know how to do. So let's start with our special properties. All right, so on the left, okay, I have the expression a raised to a power. But the power isn't just any power. It's a to the log base a of m. So with numbers, it would look something like 2 to the log base 2 of 7. I just plug 2 in for a, 7 in for m. What ends up happening, if these two numbers are the same, okay, like they are here, a and a, this part basically cancels out. Okay? And all that you're left with is what was right there, and that becomes the answer. And that's it. So there's no arithmetic or anything you have to do. You just have to look for the pattern. Okay? Those two numbers are the same. So the 2's and the log cancels out. And based on the formula, what would the answer be to this one? Yeah, it would be 7. The answer is basically whatever's right there. Now, you could double check that by typing that whole thing in. It's going to be kind of messy to type in, but if I take 2 raised to the log, let's do it like this, raised to the log base 2. I haven't shown you how to do this, and I'm not going to show you how to do it this way because this relies on having a graphing calculator. I'm going to show you how to do this on any calculator. But I typed in exactly what I just had, and I get 7. Okay? So that's it. So it's really just a special pattern to look for. Any questions on the first one? Okay, second one. It says log base a of a to the r. And this is the one that Michael asked me about in the homework. Okay, we had, in the homework, I think the base was e? Yes. Yeah, if I go back to it for a second, try to find it. So back in the homework, we had this pattern where these e's were the same. And I said basically what's going to happen is it'll cancel out. That's what I'm showing you right now. If these two things are the same, all of this cancels out. And what you're left with is whatever that exponent was. Okay, I'm not going to put lines through it because it'll look confusing, but right there is your answer. Okay? So if you had something like log, and we'll do some more examples, base 5 of 5 to the x. What would be the answer to that? X. In that case, the answer is not a number, it's just whatever x is. All right, let's take a look at why this one works. Number 2, is this in log form or exponential form? About Josh. Log. Yeah, it's in log form. There's your base. There's your argument. There's the thing on the other side. So let's change it to exponential form, and I'm just going to prove to you why this formula works. What I'm about to show you, it'll be very clear why this equation works in a second. Okay. So Dave, what's my base here? Yeah, the single a that I circled. So that's my base. Okay. And then my exponent. Sydney, what's my exponent? R. Logarithm always equals the exponent. So I used the a, I used the r. What's the only thing that goes on the other side? Right? So what, the whole thing. So where did this come from? Where did we get that from?
The base.
That was the base, right? So that was that. What about this R? Where did that come from?
From the outside.
Can you be more, what do you mean by outside?
The equals R.
Yeah, it equals R, what, on the right side of the equal sign. So we use that. So what's left? A to the R, yes. Is that true? Does A to the R equal A to the R? Yeah, all that this equation is saying is that something equals itself. And I'll just get rid of those so you can see the original formula again. So equation 2, there's a name for that in geometry. You probably learned that's the reflexive property. Something equals itself. But it's the reflexive property written as a log. That's all. Right, let's try the third one. This one says that if you take the log of 1, no matter what the base is, the answer is always 0. And this is also something that you learned in Algebra 1. You didn't write it this way in Algebra 1. You didn't write it with the word log. But I guarantee it's something that you'll probably remember. Okay, Michael, is that a log equation or exponential? Log. Yes. What's my base?
A.
Yep. So A is my base. Kristen, what's my exponent? 0. And Jocelyn, what's the only thing that's left? 1. If you rewrite this equation without the log, all that it's telling you is if you take anything and raise it to the 0 power, what do you get? 1. That's a basic rule in algebra. Anything to the 0 power is 1. This is writing it as a log. On the right is how you saw it back in Algebra 1. Okay? But that's why this rule works. Right? So on the right-hand side in red, these are kind of the explanation why the rule works. Really, we just need to know the rule itself. Right? But since it's so simple to show you why it works, I'm just showing you on a couple of them. Okay? And the last one says log base A of A equals 1. So as long as your base and your argument match, the answer is always 1. Okay, so Sydney, is that one a log equation or exponential? That's log. Dave, what's my base? Can you explain a little bit more which one?
A, the subscript.
Yeah, the subscript. That's my base. So I'm going to write A. Riley, what's my exponent? 1. Logarithm always equals the exponent, so we got that. And Michael, what's the only thing I haven't used?
The big A.
Yeah, A right there. What does that say? Question? Yeah, it says, can you read it, be more specific? Can you read the whole thing?
Anything raised to the power of 1 equals.
Exactly, that's exactly what it says. Anything to the first power equals itself. And that's all that rule 4 is. That's the log form of what she said. That's the exponential form of what she said. That's all. Okay, so those 4 special properties, there's not really any arithmetic to do. You just have to recognize the special pattern and then apply the rule. Okay, so again, what's written in red, that's kind of the explanation why. And we did a couple examples. Okay, so let's try a couple more. 1A. Hey, Jocelyn, what rule does that one look like? We have 1, 2, 3, or 4. Yeah, that's rule 1. In this case, A is 2, and M is pi, or 3.14. So, Dave, what would that simplify to? Pi. Excuse me. Thank you. So, when you have rule 1, the answer is basically whatever's right there. Everything else cancels out. And I showed that to you. I typed it in the calculator. So we already did one like that. Sydney, how about this one? What rule does that one look similar to? Which one? Yeah, that's rule 2. Okay? It's rule 2 where A is 0.2 and R is -4. So Riley, if we simplify that, what do you get? You get -4. That's it. This one's a little tricky because something is hidden. But does anybody see what rule this one is? Dave? So to be rule 4, you would have to have no exponent here.
Oh,
It's kind of like rule 4, but it's like we have something extra up there.
it just looks like that A is the exponent, right?
Any other thought what rule this one is? Jocelyn? It is rule 2. Now, to me, it doesn't look like rule 2, but can you explain why it's rule 2? There should be something that matches. I don't see anything matching here, the way it's written.
Ln equals log base b.
Exactly. This part, I can rewrite like I just did. Now, if you copy the rest of it, now it looks just like rule 2. So what would the answer be here? If these two bases match, and the answer is where R would be, what's my exponent? Michael? KT, whatever K times T is. Okay, let's see, we didn't do an example of rule 3. I could just make one up. Let's say I had log base 7 of 1. What would be the answer to that? Oh, Kristen? Let's change it to exponential form and see what happens. So I don't have anything right here, so what could I put for now? Just put an x. What's my base? 7. What's my exponent? X. And what goes on the other side?
1.
The 1. So what this is basically asking you is what power would you raise 7 to and get 1 as the answer? 0. Okay, so if you ever forget the rule, you could always change it back to an exponential problem and do it that way, but it's a little faster if we can just remember the rule when it's written as a log. So x is 0. Okay, and the last one, let's try log base 12 of 12. Jocelyn, what would log base 12 of 12 be? 1. Exactly. So if you thought about E as an exponential rule, it's basically asking you 12 to what power is 12? 12 to the first power is 12. But if you remember the log rule, you don't even have to think about it the way I just said. Just remember the pattern. Makes an argument the same? The answer is 1. So now with the information I've given you, the homework problem that you would ask me about, Michael, should make a little more sense. In fact, it's almost exactly like this one, where the e's cancel out. Okay? All right, so that's the first part of what we're going to study. Okay, 4 special formulas that are like patterns. Second part, we're going to look at some properties for taking 2 logarithms and combining them together, or you can take what's combined and split it apart. So we're going to look at problems kind of like this. These can be combined. And there's something key here that allows you to combine them. Anyone think they know What's happening here that allows you to combine these? Yep,
They have the same base.
that's the key. They have to have the same base. So, what I have written here, this equation, I kind of gave you the right-hand side in that other problem. I had two logs that were separate. And the directions on that kind of problem would ask you to combine them. Right? Or, if you have a product of two logs, okay? So you had something like log base A of 4 times 5. You can take and split that apart. Okay, not combine it, but you could split it apart as a sum. So important thing here, a product inside the log splits apart as a sum. The first factor is the first argument. The second factor is the second argument. And whatever base you started with, that's exactly the base you use when you split it apart. The base never changes. So here's an example with actual numbers below. And I'll do this on the calculator just to show you that this works. Now, to keep it simple, I'm going to use a base that the calculator can do, but you could use any base you want, and this would work. How could I keep it simple using a base the calculator could do? What base could I use? 10. So I'm going to do this with base 10. So I'm going to type in the log of 4 times 5. Type that in. Log of 4 times 5. And notice what I get. I get about 1.3. Now I'm going to type log 4 plus log 5. And I get the same thing. Okay. So I'm not going to do that for every problem, but I'm just showing you that you can take a product and split it apart as a sum. Can anybody think of another way you could split up this number? What is that number? 20. So what's another way you could split up 20 into two numbers? Yeah?
You can use the logic.
Okay, so what else could you do?
2 and
Yeah, you could do log 2 plus log 10. Any two numbers that multiply to give you 20, you could split it up as addition. You could do 40 and 1/2. That would also work. Because 40 times a half is 20. Okay, so any questions on that? That's our first rule. And this rule works for more than just two things. Like let's say you had log x, y, z. How do you think that would split up?
Log x plus log y plus log z.
Exactly. Log x plus log y plus log z. Right? So as many things as you're multiplying together, you can split it up into that many terms. 1, 2, 3. Right, let's look at our second rule. Based on the first rule, anyone have a guess how you would split a fraction? Multiplication splits as addition. That's the first rule. How about division? How do you think that would split? Josh? Yeah? Yeah, go ahead. Subtraction. Division would split as subtraction. One thing you have to be careful with subtraction is now the order matters. With addition, not really. Okay? But subtraction, you always want to do log of the top minus log of the bottom. Keep the base the same for the whole thing. Okay, so if you want to see an actual example, okay, with numbers, there you go. I'm not going to type that in on the calculator, but you could double check it. It will work. And again, just to make it clear, these formulas work with any base. Base could be 10, it could be 7, the base could even be e, so you could do this with ln's. The ln of 4/5 equals the ln of 4 minus the ln of 5. ln is just a log with a base of e. Okay, I said you can use any base you want. Okay, and I'm going to show you something first, and that's going to give us our third rule. So leave however much space you needed to write rule 2, leave that amount of space, because we're going to write one more rule. But I'm going to show you where this one comes from. We can figure it out using the rule we already know, or one of the rules. Let's do log, and I'm not going to write a base. I can use any base, it doesn't matter. But what is the base if I don't write it? 10. Okay, so we're pretending it's base 10, but it can be anything you want. Log of x cubed. What does x cubed mean? If you had to write that out for somebody that doesn't understand what it means to put a 3 up higher than an x. What does that mean? Yep. Yeah, it means x times x times x. It's the log, and you're multiplying 3 things together. Well, that should look kind of familiar. The only thing is the 3 things you're multiplying together are the same. They're not different. So if I was going to split that apart, how many terms would it split up into? What, Dave? 3. And what would we put between each term? An addition sign. So we would have log x plus log x plus another log x. What's the log of x plus the log of x plus the log of x? All right. No, that'd be if it was multiplied. This is added. So think, what operation do you do when you do repeated addition? What operation is that? Yeah, Dave?
I don't know what the operation is, but I know the answer to that.
So like in grade school, instead of doing, like, say you wanted to add 5 plus 5 plus 5 plus 5 plus 5 plus 5. Well, there's an easier way to do that. If you're going to add the same number over and over, you really could just do what? Yeah?
Multiplication.
It's multiplication, right? If you're going to do like 3 plus 3 plus 3 plus 3 plus 3, why don't you just do 3 times 5? That's a quicker way to do it and say it. So log x plus log x plus log x. It's going to be some kind of multiplication here. It's going to be 3 log x. If you're going to add the same thing together 3 times in a row, just multiply it by 3. It's the same thing. So does anybody see how we could get that from what we started with without going through the step in the middle? What's all that happened here? Yeah.
You just bring the 3 to the front.
Exactly. But I wanted you to understand why you can bring the 3 to the front. Right? This is why. So you're allowed, if you have exponents inside an argument, to take and bring that to the front. Okay? Just like I did right there. Okay? And I showed you another example right here. Log base 10 of 3 to the 5th. You're allowed to take that 5 and put it in front. Okay, so that's the last rule that we need to take logarithms and either combine them together or split them apart. There's one other fact you need to know. It's not a rule, but it is something from algebra. And it has to do, does everybody have that, what's in the box? Okay. It has to do with a square root. Does anybody remember another way you can write a square root without the square root symbol? You can do this somehow with an exponent. Does anybody remember what power is the same as a square root? A 1/2, exactly. Why would we ever do that? Well, you'll see when we start using these rules. I like to think of a square root as hiding an exponent. Just like I like to think of ln as hiding the base e. Well, square root hides an exponent. It hides a 1/2. Okay? And if you ever forgot that, or you wanted to verify and double check it, what do you get if you take the square root of 16? 4. Let's try 16 to the 1/2. 4. So raising something to the 1/2 power is exactly the same as taking a square root. Okay? So again, that's kind of just from algebra. All right, so now we'll practice taking something that's already combined and splitting it apart. Okay, we're going to start with some easy ones, and then we'll build up to some that are a little harder. First thing you want to do is look inside the parentheses. Sydney, is that multiplication or division? Multiplication. Do you remember how multiplication splits? Is that a sum or a difference? It's a sum. So we're going to have 2 logs. Michael, what's going to be the base
4.
on each log? Yeah, 4. It stays exactly the same. Okay, Kristen, what's going to be my first argument? First argument is my first factor, 3. Jocelyn, my second argument? X. And that's it. That's how you take that log and break it apart into 2 pieces. Questions on that? Okay, let's try one that has another rule in it. Log base 2 of 5 times r cubed. Okay, so Dave, inside the parentheses, do we have multiplication or division?
Multiplication.
Yeah, overall it's multiplication. It's something times something. Forget what the 2 somethings are. They're multiplied together. That tells me it's addition. Sydney, the base, when I split it apart on each log, will be?
2.
Yep, 2. And 2. Riley, what's going to be my first argument? 5. And Michael, my second argument?
R cubed.
R cubed. Okay, now, if you look at the directions carefully, it said express powers as factors. Basically what that means is do not leave exponents in your final answer. Okay, move them in front. So, Jocelyn, is there anything here that's an exponent?
Yes.
Yes, what is it?
The long base 2 corresponds to the cube.
Yep, that 3 on the R. And where does that 3 have to go?
To the front of
To the front of the whole thing? No, just to the front of its own log. Okay? So plus 3 log base 2 of R. That's the answer. So if this was a multiple choice question on the test, and you stopped at this step above it, I would mark that wrong. Okay, you didn't completely follow the directions by moving exponents in front. Okay, so just don't forget to move exponents in front. That's the same directions you'll see on the test. Okay, Sydney, what's going on here that's different than the last 2?
It's division.
It's division. So Riley, when we have division, how's that going to split?
You're going to subtract.
We're going to subtract. Michael, we're going to have 2 logs. What's going to be the base on each one?
9.
Perfect. 9. 9. Kristen, my first argument.
X.
Jocelyn, my second.
2.
2. That's it. Any questions on that one? Any exponents we have to worry about? No, not on that one. Okay, let's try this one. This one is similar to example B we just did. Okay, it's like one extra step, and we can do that extra step at the same time. Now, you don't need to write log base e. Just use the abbreviation. They used ln's, you use ln's. Okay? So Dave, how's this going to split? Sum or difference? How do you know? Because it's division, exactly. We're going to have an ln minus another ln. Okay, what's going to be my first term? And can anyone give me the final answer after you do everything you need to do? Dave?
3 LNY.
Yeah, 3 ln y. So he put it as y cubed and moved the 3 in front at the same time. My last term, ln 8. Hey, any questions on that one? All right, could do that one. Let's do this one. So this is about as hard of a problem as we can get to split logs. So the first thing I do when I see that is I see a fraction. Okay, always deal with the fraction first. You have something divided by something. Okay, so Jocelyn, if I split that up because it's division, how will it split?
With
Subtraction.
subtraction.
Okay. So write down log of the top minus log of the bottom. And what we're doing now is we're taking this complex problem and we're going to split it into smaller problems. So now we have log of the top minus log of the bottom. Okay, the first part. There's something here I mentioned about from algebra that we need to be careful with. What did I say that a square root is hiding? A half, and what is the 1/2? It's an, yep, it's an exponent. Okay, so what I'm going to do right now is I'm going to keep the second term the same. I'm just going to rewrite the first term like this. Log base a of x squared plus 1. And instead of saying take the square root of it, I'm going to say 1/2. Okay. And you know what? At the same time, we should probably start to simplify the second part. Otherwise, we're just going to copy down the entire second part the same, and then we're going to have to simplify it. Okay, so this way, we won't have to copy it as many times. Okay. Dave, inside the parentheses here, what's going on? Do we have a product in there or division? Yeah, we have a product right there. We have something times something. Forget that there's exponents, forget there's a plus 1. You've got a product of 2 things. That's what we're going to deal with next. So Sydney, how is that product going to split?
Addition.
Addition. Now, what I'm going to do is I'm going to put brackets around everything I split. Anybody know why I'm going to do that? Yeah?
So you don't confuse yourself.
Okay, what do I want to not get confused about? There's something written here before the brackets that's important.
The minus.
That minus sign. If you take this log and split it apart, this log had a minus sign in front of the whole thing. So if you split it apart, that minus sign has to apply to the whole thing still. That's why I put brackets. It's kind of like a distributive property. Because Sydney told me I'm going to split it as a sum. The first one is going to be log, my first argument, Riley?
X cubed.
Yep. We'll deal with the exponent in a second. And my second argument, log x plus 1 to the 4th. And that minus applies to this and that. If you didn't put the brackets, it would only apply to the first one. It wouldn't be distributed. Okay, so that brackets are important. Right, now I'm basically done, except I've got to do the same thing in 3 different spots. What do I have to do to all 3 terms I have? Yeah.
Put the exponent
And where can we put them?
in the front.
Put them all down in front, and that's the final answer. So 1/2 log base A, x squared plus 1, minus 3 log x, plus 4 log x plus 1. And that's about as complicated of a problem as you can get. But if you just break it down step by step, just use those same 3 rules. There's never any other rules than those 3. The only thing you don't want to do that I usually see on this kind of problem is people forget about the square root. They forget that that's hiding a 1/2 exponent. And they write their final answer something, they do it like this. They remember to move the exponents in front for everything else, but because the square root, it wasn't obvious that it was a 1/2, they put the final answer like that, and I mark it wrong. Okay. So make sure you write it like that. Okay, so any questions on that one? Yeah.
What about the x squared and
What about the x squared? Oh, this, you can't move the exponent because something is added to it. Okay, we don't have any rule for logs if we have addition inside the argument or subtraction. The only rules that we have is when you have 2 things in the logs that are multiplied, then you can use a rule, or if they're divided. This is added, so there's nothing we can do. Same thing here. This is added, nothing you can do. Yeah, that's good. Good question. All right, so now we're going to look at the other way, okay, combining it. I think splitting it is harder because you're taking something that's already nice and simple, it's all combined together, and you're making it more complicated. Okay? You're making it into more stuff. Now we're going to take something that's more stuff and put it together. So at each step, things should get simpler. So I like doing it this way better. And to do this, just think about everything we just did in reverse. Okay, reverse everything. So we have a 4 in front. Where would that 4 have been if it moved down to front, in front? Dave?
The exponent of 3.
It would have been an exponent on the 3. So put it back. Okay, that's the first step. Log base A of 7 plus log base A of 3 to the 4th. If you wanted, at that step, you could have done 3 to the 4th power. I'm going to do it right now, so I get the answer. So 3 times 3 is 9, times 3 is 27. What's 27 times 3? $81. It just makes sense to do out that arithmetic so you don't have to keep that 3 to the 4th hanging around. And now the last step, we've got 2 logs with a plus sign between them. What does that mean the 7 and the 81 must have been originally if they split apart as addition? How were they originally? Yeah. They must have been multiplication. What would be the base when I recombine it into a single log? Sydney? Yeah, the base will be A. And the argument is going to be the product of 7 and 81. You're going to recombine them as multiplication. And 7 times 81 is 567. You can just use a calculator if you're not sure. And that's it. And once you've combined it back together, there's no way to split it again. Okay? It's kind of like mixing different color paints. Once they're mixed, they're mixed. You can't really get it back the way it was because you might have a lot of options to split it. Like, let's say, just think of a simpler number. Let's say this number was 20. Well, it could have been 10 times 2, Could have been 4 times 5. It could have been a lot of different things. We wouldn't be able to split it again. Okay? So now it's combined together. Okay. Any question on that? All right. Why don't you guys try that one? See if you can recombine that into a single log. Okay, and then we'll take a look at it. Okay, so anyone think they can tell me in one step what the final answer would be? About Michael, do you think you got that one?
I put log 3,
Log, yep, base 3.
base 3, sorry.
Yep, no problem.
And then I put in parentheses u squared times v.
So you had u squared. I like the u squared. The only thing we got to be careful is it was subtraction. So when you recombine subtraction, what operation is that?
Division.
Division.
Should be over v.
Over, yeah. So u squared over v. And that's it. That's the final answer. Questions on that? All right, let's try this one. Okay, first thing I would do is put that 2/3 back as an exponent. So ln of 8 to the 2/3. Now, we just did this earlier. What's 3 to the 4th? How much? That'd be 3 cubed.
Yeah, okay.
81. So we might as well just do this out. It's 81 minus 8. Okay. How much is that? 73. So ln of 73. If there's arithmetic you can do to simplify it, you might as well do that. Now, does anybody know how to do this without a calculator? 8 to the 2/3? Okay, well, the way you do it is the numerator is the power, and the divided by the number is the root. So the 2 is squaring, the divide by 3 means cube root. And you can do them in either order. You can square first and then cube root. Or you can cube root and then square. You get the same answer. Which one do you think is easier to do first because it'll keep the numbers smaller? Do the cube root first because it's divided by 3. What's the cube root of 8? 2 squared. 4. If you did it the other way, you would square the 8 first, and you get 64. And then ask yourself, what times what times what is 64? 4. 4 times 4 times 4. So you can do it either way. And Josh, then what would be my final answer when I recombine those last two?
4 over 7.
Perfect. So this one comes out to a number. You could type that in on your calculator and get the answer. Okay. For this one, I'm not going to. Okay, we just want to recombine it and stop there. So any questions on C? Okay, last one. So this, it looks kind of complicated, but I think we're going to be able to do it in one step. Okay, the first one is an x plus a 9 plus an x squared plus 1. Plus, plus. How do you recombine things that are added? What do you do with the things that I underlined? Just? You multiply them. An x times a 9. Well, we normally don't write x9. We normally do 9x. So we have the x times the 9 times the x squared plus 1. And then it's minus log base a5. Dave, what's minus mean? division by what number? 5. That's it. So I multiplied all the things that had plus signs, and then I divided by the thing that was subtracted. So it looked like it could have been kind of a long problem, but it's really not. Okay, so any questions on the second part of what we did? Taking logs and combining or splitting them apart? Okay, so the last thing is just how do we type stuff in on the calculator. So, the calculator can only do 2 bases. Okay, we've talked about it before. Base 10 and base E. But what if you want to type something in that's other than those 2? Well, if you have a graphing calculator, you might have seen how I did it earlier. There is a button that you can use. Okay, the calculator's not coming up. But there is a button you can use, and you can type it in. But what if you don't have a graphing calculator? Okay, what if you just have a regular, just a scientific calculator? There's still a way you can do it. It's called the change of base formula. I'm going to show you where the change of base formula comes from. After I show you, then we're just going to have a formula we can use. Right now, I've got a formula for y. Have I shown you how to type in any base besides 10 and e yet? No. So what I want to do is come up with a different formula for y using what we already know how to type in, either base 10 or base e. Okay, so keep that in mind. I'm trying to come up with another formula for y. Let's start by rewriting this entire equation as an exponential. Michael, what's my base?
8.
8. Kristen, my exponent?
Y.
Y. And Jocelyn, what would go on the other side?
X.
X. Now, here's something that we haven't done before, but I think you've probably heard of this. Whenever you work with equations, if you do something to one side, what else do you have to do? Yeah?
Yes, do it on
You're going to do it on the other. So what I'm going to do in this equation is I'm going to take the log of both sides. That's fine, as long as I do it on the left and on the right. Now that I did that, something that I can use on the left-hand side, a rule we learned today. What can I do with this y? Jocelyn? You can put it in the front. That y is allowed to move in front. So I have y times log a equals log x. Now, how could I get y by itself there? What would I have to do to move that log a to the other side? Okay. Divide by log a. So, if it was y times 3 equals 10, and you wanted to move the 3, just divide by the number that's next to y. Okay. In this case, the number next to y is log a. So divide by log a. Divide by log a. Riley, what cancels on the left?
The log A.
The log a. What's the only thing that's left? Y. Y equals. I just came up with a new formula for y. Different than the one I had before. But this formula says y equals log x divided by log a. Now, I didn't write a base. So what base am I assuming? 10. Do we know how to type base 10 in on the calculator? Yes. So that is something you'd be able to type in. So does anybody see how I went from this to that without going through all the steps every time? how could you take what's in the box on the left and rewrite it so it's like the box on the right? Let's say, I'll give you actual numbers to try. Log base 6 of 2. How could you rewrite that? Yeah. Yeah. Log of the argument divided by log of the base. That's how you would type it in on the calculator. Log 6 divided by log 2. And I think I have the same formulas written again. Yeah, right there. Okay, so same idea. It's the same formula. I just used X and Y up above. So if you don't want to recopy it, I wouldn't. Don't confuse yourself. But it turns out you can either do it with log or you can do it with ln. It doesn't matter. You'll get the same answer. I would just pick one of these two ways to write down. They both work. But either use the logs or use the natural log. But don't mix them. Just pick one or the other. I usually just do it this way. Okay, so let's try this one. Kristen, how could I rewrite that so I could type it in?
Log 12 over log 5.
Yeah, log 12 over log 5. And if they wanted to know a decimal, what is it if you round it off? Let me type it in and we'll look at it. So log 12. And what do I want to be careful about before I type in log 5? Yep, got to close that parenthesis. Divide by log 5. Okay, so it's about 1.54. I'm just going to show you that if you did it with ln's, it would come out exactly the same. Doesn't matter which way you do it. Okay, so I'll put that. Okay, any questions on that? So it's pretty straightforward. That's all you have to do to type in a base that's not 10 or 8. Log of the argument, divide by log of the base. And that's just another one that's the same. Anyone need to see another one like that? We're okay with those? All right. Okay, so that's it for the second part on logs. At this point, you know everything that you need to know for formulas and properties and stuff like that. So tomorrow, first thing we do is going to be an example right off the bat. There's nothing new for nerds. So the homework, it's on 485. 7 to 15 odd, 31 to 33, that's all. And then it kind of skips around, 39, 40, 51, 52, and 65 to 69 odd. Okay, you will need a calculator. What I'll do is I will take out the calculators now, so if you don't have one at home, you at least could do the ones that require a calculator in class. Also, for extra help, I think I'm going to stay on Wednesday, since your test is Thursday. If you need extra help, Wednesday would make more sense. So I'll be here after school tomorrow.